Thank you so much, Nancy, for that warm welcome. We're going to talk about how to make your QA metrics and measurements matter. We all have wonderful measurements within QA. The key here is to make them matter to someone else. Help sharing those ideas within your project teams and to your key stakeholders. Our topics for today are going to be blink and you won't miss it. Tell me a story. Ta-da! From data to visuals. And we'll talk about the creative process and tools, most of them free. All right, what did you see? I'll give you a minute to put that in the chat. All right, I see some of you saw a smiling child. So not only did you recognize that image in the blink of an eye, but you even were able to identify the emotion that that person, this child, perhaps had. The human brain is amazing. It can process images, and it only has to see them for as little as 13 milliseconds and process them 10 times faster than the blink of the eyes. Yes, our processing is so fast that we're taking in this information without even realizing it. Now, let's think about our attention span as well, because it's great that we can take information in, but we kind of have to pay attention to it, don't we? Well, we've seen that we can take in information extremely quickly, 13 milliseconds. As we focus our attention span to get perhaps more detail, we recognize that in a 2013 study, the average human attention span was identified as 5 seconds. At almost double that, with 9 seconds, the attention span of a goldfish. Now, I'd like to think that our attention span is greater than 5 seconds, but the good thing is, because we process visual information so quickly, by providing information in a visual format, we can help get our message across quickly, efficiently, and effectively to our audience, even when their attention span isn't at its best. As we think about taking in information visually, John Medina in his book Brain Rules states that vision is by far our most dominant sense, taking up half of the brain's resources. All right, well, no wonder our brain processes visual information so quickly. This is why it's so helpful to present information visually. Now tell me a story. Think about your favorite bedtime story from when you were a kid. You had one, didn't you? I bet you still remember that favorite bedtime story. You might even remember it well enough to retell it to someone else today. That's the power of story. It really sticks in our brains. And why is that? Well, there's 4 key reasons that it sticks in our brain. One is the process called neurocoupling, which is where the story activates parts in our brain that allows us to envision these experiences as if they were our own. There's also a function called mirroring, where listeners not only experience similar brain activity to each other, also to the speaker. So it's like they're right there with us, experiencing the story. The brain releases dopamine, especially when it experiences emotionally charged events, like, oh, I don't know, a good story that really brings us in there. This makes it easier to remember. And as a result, not only do we remember more effectively, we remember more accurately because of that emotional connection to the content. We also get lots of cortex activity. A well-told story will engage the motor cortex, the sensory cortex, and the frontal cortex. So our brain gets really engaged with stories. You combine the stories and the visuals, and you've got information that sticks. Now, speaking of visuals, I'm looking at these, and I see lines and dots. I see labeled axes. I see some numbers, but I've got no story, no context, no reason any of this makes any difference to me whatsoever. It's not very effective. I'd almost call it chart junk. Now here we have a nice cave painting. We see two hunters. We see animals with arrows sticking out of them. Now we've got a little bit of a story, but we don't have a lot of context. We don't know if these two hunters are part of a large group, a small group. It could even be the same person in more than one hunting scenario. We just don't have enough information to derive a solid story from it, but you might be able to make something up and fill in the gaps.
So when we're talking about storytelling, we talk about what should be done with the data. What's the meaning of the data? Why is it important to your audience? Who is your audience? And how is the information going to be delivered? Because if you slap it on a wall with no explanation, that's delivery, but you're not going to have enough information. So you really need to think about how you work with the data. We love our stories, but we want our stories and our data to be meaningful. Now, here's an example of an image that tells a story and provides meaning. Have you seen the FDA food pyramid? I know I saw it when I was in school, like grade school back in the day. This, unfortunately now outdated chart, really conveys a lot of information really helpfully. It provides that big picture at a glance. We're looking at this model that has been revised over time. It was so successful, they transitioned it from the food pyramid to my pyramid, then to my plate, because they couldn't just go from this pyramid concept to something else, because the pyramid stuck so well. We think about what should be done with this data. Well, it's really providing dietary guidance. It's providing information so that we can make good choices. That's the meaning of the data. We want to have a balanced diet. Well, and then why is that important? Well, we want to eat healthy, and it's important to us because we want to live longer, healthier lives. It really matters. Who's the audience? This simple graphic was designed in such a way that both children and adults could process the information at a glance, understand the meaning of it, get the importance and the goals, just like that, snap of your fingers. And then when you think about how this information is being delivered, there were kits sent to schools. They sent these packages in. That's how they were delivering it to kids. And then for the adults, there were advertising campaigns. Might have been on TV, on the internet, any number of ways. Now we've got all this data. We understand that pictures are important. We understand that storytelling is important. We want to take it from the data we have to the visuals to really figure out how to combine this information and tell the story. This particular graphic was designed as part of Carl Sagan's book. It was called The Dragons of Eden. I look at this graphic and I see lots of dots and lots of arrows, and I have no idea what the story is. I mean, I see that there's brain mass in grams. I see that there's body mass in kilograms. I'm not sure where this is going. Makes it hard to tell a story. It's got lots of information, but I don't get it. Now, Edward Tofte thought this Dragons of Eden was really an interesting project. He's kind of the father of data visualization. If not the father, he's certainly quite the expert. The Dragons of Eden can be reimagined with a little bit more of a visual. He also added a few fun elements. You can put it in chat if you found some of them. As you go up the chart, one of the things you can see is the smaller creatures at the bottom of the chart have smaller brains. Well, that kind of makes sense. They're smaller in size, smaller brains. But these really big creatures have smaller brains then these not nearly as big creatures. Oh, hey, the brain size is different. Whereas in contrast, the whale has a brain size that's pretty close to its size. It's scaled. All right, did anybody find Babar? How about the centaur? Little fun things that Edward Tofte put into his chart. Now let's take this into software, because after all, we work with software all the time. Software quality assurance is very important. Let's look at the relative cost of fixing a defect. It's not really a surprise to anybody on this call that it's a lot cheaper to fix the defect in requirements before it's even been coded than to fix it after it goes to production. And you can see that the chart moves up and up all the way to the top at 150 times and greater, depends on how many people you have to get involved and how big an issue it is. Well, it kind of gets the idea. You get that it's a relative increase in cost, but I don't think this alone is going to convince anybody to change their practices. We've seen too many times the adage of, well, if we can't afford to do it right the first time, how can we afford to do it over? Yeah, we do that, don't we? I reimagined this chart. When you're looking at the relative cost of fixing a defect, it's not just about increments of numbers, it's about dollars. And so these are coins that represent money. Requirements, 1 times the cost. Unit testing, 20 times the cost. So for every dollar it costs you for requirements, it's $20 in unit testing. Post-release, $150 or must get paid $1 an hour. You can really see the money, the impact in this particular graphic. I will add that this was just done in PowerPoint, no fancy tools. Anybody could do this. Now we get into the fun part. Actually, I think it's all fun. The creative process and our tools. We're going to start with a mnemonic, adapt, because this helps me remember as I'm thinking through the storytelling of my data, what I need to do. I need to analyze the data. I need to define the story. I need to identify some nice appropriate visuals, prepare a draft, and you can't forget about testing those results. Because sometimes what sounds good in your head doesn't work as well when you bring it outside. All right, we've got this fictional situation. We're in sprint 13. It's a 4-week sprint. It had delays in completion of the user stories and in completion of development. Each of them were 5 days late. And in a 4-week sprint, those 5 days are not insignificant. As a result, QA has now forecasted a testing completion date that's 1 business day after the planned go live. Yikes. This is 4 business days later than they planned. Hey, QA's actually made up a day somehow. Today is the go-no meeting, top of the agenda. Why isn't QA done? Oh my gosh. I have a little poll here that I want to start doing. Let's see if I can launch the other poll. And then get to the other one. All right. Have you been on a project like this? It's the 11th hour, there were delays, QA's impacted, and they're wondering, well, what's wrong with QA that you're not done? I see a lucky few people have never had this experience. I certainly cannot say I've never had this experience. We're still getting responses. I'm going to give it another 10 seconds. All right, let's share the results. All the time, 10%. Many times, a whopping 2/3 of the folks who responded. A few times, just 17%, and never a lucky 7%. What does that tell us? Well, that tells us that this is a pretty common experience. Most end of the wire, and the question was, why isn't QA done? So we're going to analyze the data. Now I've provided some fictional data for us to analyze. User stories were delayed by 5 business days. Code completion was delayed by 5 business days. That seems a logical cause and effect, right? Requirements are late, coding can't finish either. You kind of need to know what you're building. We currently have open high defects, 2 of them. Ew, we don't want to go to production like that. There are only total defects open of 14. Not too bad. We have 436 functional test cases, with 418 of them having passed, 3 failed, and 15 can't be executed until open defects are resolved. Sounds like we have a good chance at finishing relatively quickly here. We are finding more defects daily, but our rate of identification is starting to slow. And our regression testing takes 2 full business days. It would be great if we could finish all the testing the same time all the development's complete, but regression testing, as we all know, requires us to be just a little further along. So now we're going to define the story. We had delays in earlier deliverables that impacted the testing timeline. We can't start testing if there's no code. We do have current unresolved defects that are impacting our ability to finish. We think most issues have been identified. It's a guess. We can't start regression testing until we get rid of these high issues, however. The other thing we know is if we release the current code base to production, there will be issues. We have 2 reported high defects. Because we have not executed regression, there's also a risk of unknown issues causing additional problems. This is a pretty real scenario. I was on a go, no-go call with one of the jobs I worked at for an e-commerce site. Code was late. We had issues. Here we are. We want to deploy it to production, but QA isn't done. And everybody's looking at QA like I'm the problem. No, I'm not the problem. On the call, because I was actually traveling for work at the time, I pointed out that, yes, QA found a high defect yesterday. Once that's resolved, we can retest, validate. Oh, by the way, that was in the order flow for this e-commerce website. And there is a risk that because we haven't had time to do regression, there will be issues in either the order flow or other critical areas of the website that weren't impacted by the code changes directly. Oh, now suddenly the business isn't asking, why isn't QA done? The business owner is now asking, how long does it take to reduce the risk that orders would be impacted negatively when we go to production? Ah, now it's all of our problem. That's the power of the story that goes with the data. I said, we needed 2 more business days. All right, you've got them. We'll talk again next week. Congratulations. We went to production, no further issues because we had the time we needed to do the job right. I'm going to contrast this with another project I was on. Urgent fix, urgent fix. It's only going to affect the clearance section of the website, they tell me. Being a QA person, trust but verify is kind of my mantra. I'm like, well, yeah, but I still need to do regression. They're like, no, it only affects clearance. The developer promises their change will only affect clearance. And I turned to the business owner. Are you comfortable accepting the risk that these changes will impact something other than clearance? And you're telling me to only test the clearance section of the website. Anybody want to guess what happened when it went production? Put it in chat if you got a guess. Well, I did only test the clearance section of the website as was requested. And the clearance section worked great. Once we promoted to production, we discovered that the clearance section worked great. Nothing else did. It blew up is a good way of putting it. Only the clearance section of this product-based e-commerce website worked. Nothing else did. Logically, they backed out that code and we went back and did it right. Again, this is why we trust, but we like to verify this, and got that agreement all up front. It makes a really clear story and helps people understand why regression matters. The developers swore up and down that only clearance was impacted. Well, only clearance worked when they were done. So clearly they were mistaken about the impacts. They don't always know. They didn't build 100% of it. It makes it tough. But having these stories in your tool belt helps people understand the importance of regression, the importance of really thinking about what you're doing and the impacts to the customer for what you deliver. And that's how you flip the script and get it away from all about QA and pointing fingers, which I hate, back to we're all in it together to have a successful release, successful product. So we've defined our story. Now we want to figure out what are some appropriate visuals. You can do it in Excel. I sometimes will try different charts until I find one that seems to look right. You can even draw it out on a piece of paper just to get an idea, or a whiteboard. Think about how you can represent this information with text. And then, is there more information needed to complete the story? So as you start thinking about your visuals, you wonder if you've got all the data you need. You might be missing something. You might need to go back and ask questions. That helps you make sure you've got everything for a full picture to enable that informed decision making. For our fictional event, I've got a draft prepared for our defects. What you can see is our friend, the S-curve. And as you know, with the S-curve, you want to see it flatten like it's doing right here. It's flattened only recently, instead of that steep ascension that we were seeing back on the 23rd to the 25th of March, where we were finding a lot of defects. As it levels out, you recognize that you found most of the defects that you're going to find. Yes, there might be some you miss, but exhaustive testing is never an option. We're definitely seeing the number of open defects also start to reduce. That gap is closing, which means we're getting close to that stable code base that we want. One more build should do it. How about our open defects? Well, hey, there's no critical ones that are just blowing up the entire site or the entire application. We do still have 2 Sev2 defects, high defects, and the remaining defects are Sev3 or medium defects. They may or may not need to be fixed, and that's something that our business partners will decide. But those 2 that are high, our processes were defined such that if it's high or critical, it's got to be fixed before go live. And now we have our test execution summary. And this is why I say you can tell that you don't have a whole lot of work left on the functional test side, as we've been running about 50 or so test cases per day. You can see that nice trend. You can see this squishing where the past starts getting bigger and bigger, and the no action ones are small, just those 15 test cases, with the line for failed kind of tiny. We'll have to see how this goes when we test the results. All right, the defect curve is leveling out. The gap between open and closed defects is narrowing. Yeah, that works pretty well. I think that conveys the information. You can see that the code stability is getting to be there. We're not breaking a bunch of stuff with every build. Those 2 remaining high defects really need to be resolved. You can see where they're at. There's still not a lot of defects. There's only 2 Sev2 defects. Maybe there's another way to represent it. Maybe it's just say, hey, there's 2 defects we have to fix. And we start talking about those high defects. The remaining functional test cases can easily be executed in a day based on our current progress, because we're getting about 50 a day, and we only have 18 test cases if you add the 15 that we haven't run yet and the 3 that failed. But boy, is it still a little bit of an eye chart. Maybe there's some opportunities. And this is where, after we've tested the results, we want to ask ourselves some questions. Like, what else might we want to include? Oh, do we want to talk about the delays? Well, that kind of depends on our goal and how antagonistic our audience is, right? If we've got somebody who's really into blaming QA for everything, we may want to point out those delays and the fact that QA is forecasting completion a day fewer delayed than the other two things upstream. Hey, we're getting it done in 4 days delay instead of 5, like development and our business partners. That might be necessary. Something as simple as a calendar or even a little bar could be drawn. Real simple. Oh, wait, when we were talking about our data, we didn't talk about regression test timing. Now it's 2 days. Do we need to show those visuals? Maybe, maybe not. Depends on how your automation is for regression. If it's all manual, one of the things that commonly happens is, hey, your regression will take 2 days. Can we throw more people at it and get it done in 1? The answer is maybe, and that could be something that you want to prepare a story for and have visuals for to ensure that you're able to speak to it. Again, this depends on your audience and your environment. Almost everybody wants to hear about defects, test case counts, and pretty much when are you going to be done? And one of the things the graphics didn't talk about is the potential impact to production from open high defects. So if you know these high defects impact critical functionality, and kind of by definition, they're going to, you can speak to the end user, the customer impact of those defects. So that can be part of your story. It may or may not be part of your documentation or your data. But for example, if it's a high defect, but it's also in a high visibility part of the website, that might be some data. Hey, 80% of our customers use this. And yes, it is a high defect, not crashing the site, but it has impact. And 80% of our customers are going to be impacted by these two issues if we don't resolve them. That's something to consider. Might need to go back, get more data, put that into want to change with the visuals we defined. Well, I intentionally left some errors in so we'd have something to look at and pick apart. So that stack bar chart, boy, I saw it and it provided information, but I kind of had to squint. I couldn't see where those 3 failed test cases were because in a chart with 436 entries, those 3 were so tiny, I couldn't even see the number 3. Maybe not a great visual to use for this particular purpose. It helps show that we're tracking and we're passing test cases, but maybe there's a better way to put that information out there and say, okay, this was fine for status, but for this context, simply saying, we have 18 test cases we need to rerun. We track about 50 a day. We can finish them in about a day. That might be enough. It might not need a fancy visual. And then I'm going to pick on myself again. Did you notice I used red for failed and green for passed? Well, there's a risk there because color blindness occurs in about 1 out of 12 men. That's 8% of the population. So if you have a team with product owners and stakeholders that's 20 people, the odds are pretty good that at least one person in the room is going to have color blindness of some sort. You want to put that visual, if you're dependent on that color information, you want to put that visual through some sort of color blindness check. I have a link at the end. So you really want to make sure that not only do you have visuals, but that the people you're presenting them to can process the information and can see it in the same way that you intend for it to be seen. You may also need to do something like alt text, where you put information at the back of your visual so that people who are using screen readers to see the information can also see the information. Nobody's had questions. Well, tools I've been using. I use Excel a lot because they have some nice, pretty pictures. I use PowerPoint. I use Word because sometimes there are things you can do in Word that you can't do in other tools. I used pen, paper, and a digital camera. So you saw the brain that I drew with the half filled in. I drew the brain and I used PowerPoint to fill in the colors. Nothing too fancy, not Photoshop skills. You can use any drawing program, again, depending on your skills. And here's a link to the color blindness checker that I like to use because it lets you check for 6 or 8 different kinds of color blindness with any of your visuals. Again, it helps you make it accessible. Once you get used to which colors work, you won't need to check everything, but you'll understand, oh, hey, these colors are going to work regularly. I'm good. And of course, as you're coming up with visuals, use your imagination. I was trying to represent people on a project and how many out of the total resources that we had were working on this project. And I ended up doing little stick figure people. And I'd like slice one in half to represent half a person. It sounded like a good idea at the time, and it mostly worked, but then it became the people chart rather than useful information. Sometimes when you test it out, you get a little different feedback than was inside your head. All right, what else would you like to know? You know it all? You've got no questions for me. Oh, good visualization for technical debt. So you want to think about with technical debt, as it increases, it's not just a one-to-one. You don't have one item that takes 5 hours to fix. You kind of start stacking it up. One of the things I've used with technical debt is to show how it's increased over time. And we now have an estimate that shows that it's going to take an entire sprint to resolve the issues. And that is unfortunately usually what it takes at least the companies I've been at, is you need to show we've got this backlog. We've built this up over time, and we now have enough technical debt that we have to do an entire sprint just to address technical debt. It's pay me now or pay me later. Thank you. Any other questions?
Guess we don't have any more questions. Anyone? Maybe ask the participants what sort of metrics do they use, and
what's
get
your
your
favorite
ideas
metric?
on how to present it visually.
Yeah, do you have a favorite metric that you like to use? A favorite representation? If you like timelines, the timeline creator, there's an Office Timeline Pro that's an add-in for PowerPoint that's free. You can use up to 10 items in it. That's another tool that can help put visual information like the schedule slippage that I mentioned. That's something that is helpful for that.
Lisa has a comment.
Ah, and what does Dora stand for, Lisa? Oh, ROI on automation. All right, for test automation, one of the things that we tracked was the hours it took to run stuff manually, and then the hours that it took to build the tests, and how many regression cycles did it take before you basically get to break even. Now, we would take multiple projects and put it in a regression cycle together with automation. So the first run we had, I think we went from every project having their own automation and every project having their own regression manually and automated bits and pieces. We put it all together into one, and we had 13 projects in that regression cycle. We ended up after the first pass kicking one out because it had unresolved issues. The remaining 12 went to production, and right there, that paid for our automation investment. It made it really super clear. Release frequency, that can help. Rejected defects. Oh, pivot tables. Oh, I love pivot tables. because it allows you to do so many different things with your data, and you can slice and dice it differently without having to re-enter it. So Wendy, I love your pivot tables idea. And Lisa, mean time to recovery and release frequency. So release frequency is definitely a measurement. How frequently are you releasing? But recovery and failure, so you start thinking about when something breaks in production, how long does it take to recover from that? And what can we do to then, I would imagine there's a process improvement to go along with that. Hey, how can we recover faster or break less frequently? Lead time for changes, time to restore service, change failure rate, deployment frequency. Yeah. Deployment frequency is the good one. I had one project I was on, we were getting deployments during the test cycle pretty much daily. And that was great, except that every out of 12 builds, 8 of them gave me code where the order process didn't work. At which point I'm having a conversation with my development lead, asking them to make sure they unit test that you can actually place an order on the website, which it's an e-commerce website. It's got one job, place orders. I have to be able to place an order or I'm going to reject the code build. Quit giving me builds where I can't place orders. And that helped. And it didn't need to be a formal thing. It was, but the story was clear. 8 out of 12 times I can't place an order. So you look for those patterns, and sometimes the patterns helps with your storytelling too. So I look at like your change feeling. That's going to tell you a story. And then look for the patterns underlying that, right? Are we getting failures every time we change a particular system, like the mainframe? Maybe the mainframe's really brittle. Every time we change the mainframe, we have an issue with deployment. All right, is there an issue with the deployment process? And you can really start digging into that root cause analysis and find that underlying pattern. Are there other metrics that folks like to use? I like all the ones Lisa shared.
Well, if not, should we wrap up? What do you think?
Yeah. Well, if you completion ratio for defects completed versus submitted. Yeah, because one of the things you notice is how many are deferred as well. And I found that if you have a high percentage of defects deferred, you might want to ask about the quality. It's like, well, yeah, we deferred all these defects so that we could go live. Okay, but what's the collective impact of all those defects, right? Test case trackers like TestRail. I haven't used anything other than, I've used ALM. I've used Visual Studio Team Server, wait, it's now called Azure DevOps. Some of those can be helpful, but where we haven't had tools, we've actually used Excel and a macro to kind of pull in all the data so that we can report out test case status. So thanks for that, Steve. And really the moral of the story is you want to understand what happens with your data and how to share that information about your data with other people so that they have meaning and importance as well. What's in it for them? Why should they care about this data? What's important about this data? What's the collective importance of this data? Well, hey, we deferred a lot of defects and we're going live. Yes, but you deferred 300 defects. What do you think that site works like? You better not let customers touch that. It's reality. I love metrics and measurement because they help enable informed decision-making and they drive wonderful process improvement opportunities. And I look forward to seeing what you decide to do with your data.